It's Monday. We're back. Oops.
Very nice.
Now, look, how many times have I actually fucked up? Not many.
7.
It could be.
Well, I mean, it's out of 200 and whatever, right?
Go ahead.
Hey, we're Power and Speed, 908-751-0211.
And like us, what's that?
It's a plug-in air freshener.
Okay. Like us on Facebook, iTunes, and get ready because we're talking about the Oscars tonight, aren't we?
Did you really sit there and watch that?
I watched a bit of it just for the Roseanne commercial bit, and it sucked. So
Wait, you watched the Oscars to see a commercial?
I fast forwarded through the Oscars to see a commercial. That's about it.
Yep. You could have just Googled it.
Yeah, pretty much.
Like the rest of the world.
What's this Google you speak of?
I know. Hey, Fireman Jeff's with us. I didn't want to wait 20 minutes like Mike would have.
Howdy.
You got to ramp
Why is it all about fuck you guys getting on me today? I mean, really.
Well, you're dropping stuff, so.
I dropped one thing. You snort into the microphone. You fucking all kinds of shit. Fucking just don't even just stop that. Is your motor in your car? That's all I want to ask you. Is your motor in your car?
Yes.
Okay.
There you go. Air in the tires.
Yeah, the new ones.
You should really put winter air in.
Why it might freeze? Nah, come on. Winter's over.
All right. So the big news for me for the weekend.
Yep.
We are registered once again for Drag Week, number 251.
Yes, you are.
So,
Nice.
barring anything horribly unforeseen, who knows how the performance will be, but we'll be there. I think this time it's finally fine.
And the car's moving along.
Yeah. Yeah, actually it is.
Are we going down to Howard's?
We're going to have to.
I'm going down there end of March, and then Howard and I are going to Dubai.
Okay.
So when's the car going to be there? After that?
I don't know. I was supposed to call Tim on Friday to see, and I forgot. And then today was Monday.
Yeah,
it's
I know.
Monday.
I know about Monday.
I don't know why we do this Mondays.
Because we're half.
Yeah, I mean, like if Mondays are bad for you, I mean, I can just like walk away.
I know.
If I don't have anything.
No, they're just bad mentally. I mean, the day doesn't matter.
Really?
Well, no. I mean, after the Monday craziness of work. Yeah.
Oh, okay.
I don't mean they're bad mentally here.
All
Well, any day is bad mentally here. We got.
Nope, he's gone.
Oh,
I was going to say we hadn't talked to Anthony Ferguson.
yeah,
It would have been nice.
Yeah, well, he'll
Call back, Anthony. You're probably listening, unless he called to listen.
Possibly.
Then he's not listening.
All right.
Tad, anything?
Actually, yes.
Wow.
Well,
Have at it.
no, it's something that I just became aware of, and I like the thought of it. The 2019 GMC
Yeah.
is going to have a straight 6 diesel in it now,
Well,
the baby Duramax, and a carbon fiber bed,
I heard about that.
which looks interesting. It's not, but they have no other details on it yet, no horsepower. They just said it's going to be better than the Ford, better than the Dodge.
Well, they always say that.
Yeah, so I'm quite interested in seeing what the straight 6 diesel does.
So you're
Duramax.
cautiously optimistic.
Yes,
All righty.
quite so.
Yeah.
Had a nice looking dash, nice,
I saw that
We'll
bed thing and the tailgate's all.
yeah, it's got the multiple levels
it
and everything.
articulates.
I like
and
that.
Makes a step.
Is carbon fiber getting affordable now?
I don't know.
Yes.
Well, have you priced the GMC pickup lately?
No.
I just looked at. I looked at a price. I was running through the airport in Fort Myers.
Like the Hertz guy?
Anyway,
Oh, you could do that. Anyway.
that was good though. And I walked by this Maserati. Really good looking car, all white, black wheels, red calipers, just like I would like.
Did it have the matching interior?
No, the interior was brown, or if you were picking it out of their book, it's probably nougat or something like that.
Nougat.
But anyway, so I'm thinking this thing's got to be $1 million. I look at the sticker, and it's like 78,000.
What was it? Was those Ghibli things? Isn't that who makes that? The Maserati Ghibli?
Don't ever say
Giblet? Giblet, whatever.
Don't ever say Ghibli.
That's
again.
the name of the car, isn't it?
I don't know.
Ghibli?
It's a Maserati.
Yeah.
It's the swoopy nose, and it's got the cool
Or quadruple
inlet. Yeah, that's what it was.
All right.
A quadruport. Tay. You want to get Anthony, or you want to cut me
absolutely
off
wanna
my
get
story?
Anthony. Yeah, I'd rather stop you talking about nonsense.
No, we were
Anthony,
talking about
man, how you been?
the price of GMC pickup
Hey, how
trucks.
you been, man? I got a question.
Okay.
I got to build an engine for Drag Week,
Oof.
and I got to build it fast. And
Give it to Fudd.
I was looking at the the GM ready to assemble blocks. I was wondering what your thoughts were on it.
We just talked about this.
Yeah.
We just
really?
talked about this. Yep. Now, are you doing an LS, Anthony, or are you doing a regular small block?
No, regular 350.
Okay.
Why?
Because I have 90% of the parts for it. I just need a good bottom end.
Okay. They're ready to build stuff is pretty good, actually. I think that was our consensus,
Okay.
right?
Yeah. Yeah. We talked about it just the other day for another reason. I don't remember why. We were talking about motors being put together and sold as a kit. Tom says they're fine. A lot of people do it.
Yeah. I mean, literally clean them and put them together.
Okay. Yeah, I was going to get a rotating assembly, file fit rings. I just need to figure out ring gap for about 10 pounds of boost.
Okay.
That shouldn't be any big deal.
No, I wouldn't think so. What displacement are you building here?
350.
Okay. And what class is it going to run? Is it going to run like a class? Like, do you have a power level in mind, or?
I don't think it's going to go fast because the car is heavy and it's a small supercharger. Probably will go 12s, I think. So, Super Street small block power adder, I think it is.
Mm-hmm.
I think that's the class I chose.
Yeah, Super Street small block power adder. That's the 850 class.
Yeah.
Or
12 is going to be slightly off the
Here's
mark
the
there.
problem. They've got these classes and rules and different. I can't keep them straight. Keep them straight. But I know that's what that is. But all the other stuff, and then I don't even know if they have permanent indexes in the other classes or if they become a bracket class. I don't really know.
I don't know either.
But I mean, Anthony, if you're talking about 10 pounds of boost on a 350, it's going to make a pretty good number.
How heavy's the car?
4,000 pounds.
Bud said street machine.
I mean, you should be able to go 12s.
Yeah, street machine. Yeah, that's right. Street
You should
machine.
be able to go 12s easy without a supercharger.
I would think so.
I don't care if it's 4,000 pounds.
Yeah, I got to, that was what I guessed, that it would make about 500.
What heads do you have?
I didn't buy anything yet. I'm going to order everything.
Well, this is one of the things we talked about. We talked about all this stuff before. If you and this is why like big block engine blocks, like we would use, they're no longer gettable. You don't buy a big block at Ford 250.
No, why would you?
Why would you? So I have to, and listen, Anthony, I'm not picking on you, dude. But if you're going to build an engine, unless you had to fit into a class displacement rule, if you had to buy a crankshaft, it doesn't matter if the crankshaft's a 348 or a 4-inch or 3 3/4. I mean, I'd make at least a 406.
At least.
Yeah.
Okay. Yeah, but I thought that would be too many cubes for the supercharger.
Well, I mean, you don't build the motor for the supercharger. You put the supercharger on for the motor.
Yeah.
That's kind of how I'd look at it.
What supercharger is
This is
it?
a car that I drive every day. The Vortec V3.
Oh, you'll be fine.
We got a supercharger expert here.
Jeff
Yeah.
authoritatively says he'll be fine.
You'll be fine.
I don't know what that is.
How much power will he make, Jeff?
With the V3 on a 350, probably need some heads though. 500-600.
There you go. At tires? I don't know.
Yeah.
I don't know what a V3 is.
I don't either.
It's centrifugal.
No.
I knew that.
It looks like the thing at the end of the table.
Fucker. So what parts do you have that you're locked into this 350?
I got the exhaust. I have the supercharger with the small block brackets, intake manifold. I just need a block and heads.
Right. You have rotating, and a rotating assembly, correct?
No, I was going to buy that with the block.
Okay.
Wow, man, I don't know.
Punch it, stroke it.
I'd put it in a corner and buy an LS1, an LS something.
Yeah, I have that for the other car.
Okay.
'Cause I have 2 Malibus.
Look, it's to me, if you can build a bigger displacement motor easily and it doesn't cost you anything, that's always where I go to. Because now is this going to be something that, like you said, this is your street car? Like you're going to drive this?
Yeah, this is a car I drive every day.
Man, I got to tell you, there's nothing like a big and small block for making it nice to drive.
Yep.
I mean, just a shitload of torque on the bottom, just chugging along. I mean, they're fantastic. They're a lot of fun.
Crickets.
All right.
Come on, you got to keep talking, man.
Yeah. Yeah. So I was just wondering what your opinion was on the blocks.
I think they're more than good enough, and I think Tom would agree.
Yeah, I mean, the GMs are good. The SHP is good. You know, the Dart, you know, they're similar priced. And,
Okay.
man, I 100% agree with Mike. You're going to buy a rotator. You know, Manley's got a really nice rotating assembly, a 4-inch deal.
Okay.
But
Do you have contact for that company? You know who to call?
How would you know?
I don't. But you'll be able to get them for sure. But yeah, I mean, why not build something that's, you know, 427 inches instead of 350?
The budget. So I had to fit within my budget.
It's not going to be any more money.
No, it doesn't cost any more money.
Oh, no?
Nope.
No.
No, like all the rotating stuff. I mean, look, there might be a couple bucks one way or the other.
Like 100
yeah,
total.
yeah, it's not.
It's not a lot.
No, I mean, because like, do you charge more, like say from the Manly side
No.
to balance?
Nope.
So it
Nope.
doesn't matter.
Doesn't matter.
And everything's internal, right?
Yep.
Okay. Yeah,
Okay.
I'd make it personally for me. I'd make it a 406. I wouldn't make it a 430. That's just me. I don't like ring spacers. I don't like none of that crap, especially for a street car. My own engine. That's what we did. We made sure that we weren't into that area. But I mean, that choice is up to you. But I mean, cost wise.
But you can do that with a 5850 rod.
Sure. Yeah, well, with a 430 with no spacer, I don't think so.
Did mine have a spacer?
Yeah, I believe it did.
I don't think it did.
I believe it did.
You might be right.
I believe
You are the engine guy.
Used to be.
Yeah.
Although he's talking about shit that I remember at least.
Yeah.
We call this LS nonsense. Yeah. I listen, Anthony. When you get closer, get in touch with Tom or I, and
Okay.
and we'll certainly help you out. I mean, it's not a big deal.
Yeah, definitely will.
All right. Well, it was good talking to you, man. You still got to come by here one day.
Yeah, I will. I have to take a day off of work because I have to work Mondays. So I have to tell my boss to give me a day off, and then I'll be able to come up.
Well, you get in touch with me and you work it out, and we'll figure it out.
Yep. We'll help you
Okay.
as best we can.
All right, that sounds good.
All right, buddy. See you, man.
All right, thank you.
You're welcome. Bye bye. That's a long time listener.
Yep.
Mm-hmm.
You met him at Englishtown or something, didn't you?
Mhm.
Him and his buddy.
Him and his
Yeah.
buddy. Yep.
Yeah.
That ain't gonna happen now, but
Who's this?
Fiat Chrysler. Don't know.
Hello.
Hey,
You're early, sir.
you said quarter after.
Well, I'm looking at my clock. It says 7:13.
Oh, gee, mini cricket, Jesus. Oh, hang on. You know what? Hey, you know what? Nice talking to you.
Well, here we have Greg Banish, Calibrated Success. And we talked about, and Jeff is here again.
Howdy.
We had talked about your video, DVDs, and the whole training side of things. Up, he's gone. He actually did hang up. Hang up.
Good for him. He jammed it right in you for giving him grief.
Did you do that on purpose, or does your phone just suck?
No, you suck.
I like it. I like where your head's at, Banish.
All right. So, well, I don't have to repeat it for him. He knows who he is. But
He does.
Jeff is here, and we went through, both watched the tuning material, and the one overwhelming thing that came up time and time again is to gather as much of this dyno as you information to do the calibration was using a load-bearing dyno.
Mhm.
And I'm not knocking the dyno jet guys, and, maybe Greg will share with everybody how you could do it if it accelerates and does a run-through. But the dyno looks crucial to doing things, at least, let's say the method that he prescribed.
Yeah. Yep.
So you've been on like
So
every kind of dyno, right, Greg?
I've used everybody's dyno pretty much. I mean, aftermarket, OE, whatever, they're all pink in the middle. You just got to, it's the craftsman, not the tool, right?
They're all pink in the middle.
I didn't even want to touch that one.
I like it.
I had to
You're
be
doing
careful.
well, sir. Keep going. You're on a roll.
It's a family show, right?
Yeah. And we're all family here.
So, I mean, I don't care about brand on the dyno. I care about does it do what I need it to do. And the funny thing is, guys argue all the time, like, oh, street tune, you don't drive a dyno. I'm like, well, GM tunes 100% of their engines on a dyno. Right? All power numbers from GM come from a steady state dyno test, according to an SAE standard. Right? And even all base mapping at GM is done on an engine dyno. No transmission, no car, no sweep rate. It's steady state. So the funny thing is, the guys that, they get their power number and they maybe kind of sort of through village wisdom get it to idle. And then they want to come back and fix drivability later. And they've done like this road tune and, street driving and all this nonsense. And aside from like the safety issue, right? And I won't get on that soapbox right now, but it's just hard to keep it steady out on the road. There's too many things going on, uphill, downhill, cracks in the pavement, Michigan potholes, pedestrians, bullshit, cops, whatever. And I found that I can just get more work done in about an hour and a half on the dyno than I can get done in a week of driving around fighting traffic. If you use the dyno like a tool, you can get a lot of really good work done really fast.
Well, and let me ask you a question. Nobody ever addressed this, but it seems like there are a lot of people that just sweep through a dyno pole, and they'll gather their mass air data and their wideband data, and then do the correction from the sweep. Now, if it was a wide open throttle sweep through the top, you don't have any throttle transitions, but I mean, as the motor's accelerating, is there a reason that doesn't work as well? Is I guess what I'm trying to ask.
You want to separate. There's two different things going on in the ECU. One is the steady state base model, and the other is the transient fueling correction. So there's my fan club. So if you look at it, like the VE surface is your steady state model, or the mass airflow sensor is your steady state model. And then you have, on port injected cars at least, a fuel to wall impact factor or some equivalent of transient fueling correction. So we're trying to separate, right? I don't want to be trying to tune both of those simultaneously. I want to hit one or the other.
Okay.
Does that make sense?
No, it makes sense. I was just wondering like what the difference would be, because the impact factor and the wall on the fuel, if you were already at like say a wide open throttle acceleration, I didn't know how that log would look, how it would differ from, or honestly, there's the question of the day, and we've had people ask that question too. We would steady state on our old Superfly, and we would do it for very specific reasons to see like how a motor was really going to behave under full load at say 2000, or if it was a drag thing, like put it up like where it would be right on the converter, right below, to see how the motor behaved when it's stabilized, we'd call it. And when you go to do a sweep test, what would happen is it might need a little bit more ignition timing, or at least that's what it showed on the dyno. And Greg, forget all best timing and blah blah blah. I mean, when you're drag racing, and even if you're racing a dyno, you're looking for the number, especially with the super stock guys. They'll put it on the edge that they have no safe zone, because if they get 2 or 3 horse, they need to have that. So just the bottom line is that, can you do it without a dyno that holds steady state? I mean, is there any way to actually do it?
Tough, right? So you really got to get a couple of steady state points are reliable, so that you can say those didn't have an influence of the transient. And then you can go back to transient in those areas, then leave the transient alone and know that the transient was good, and then go do a sweep area, knowing that whatever transient is based on a good measurement earlier. Right? It's painful. It's much more. Don't get in that.
Speaking of painful,
they're only talking a 248, right? Because they make the 224 XL. You use that eddy current to do a steady state test. You got to game the control system a little bit, so they don't do like feedback control on say just hold me at 2,000 RPM. However, you say, you know what, hold me at 32 mile an hour for 100 seconds for this test, and it'll do it. And no matter what you do with the throttle, you're going 32 mile an hour and you're locked in a single gear. And hey, what do you know? That's 1 RPM.
Mm-hmm.
And so you can do it. So you can use the eddy current on that. It's just that their eddy current controls are set up a little bit different than brand X or Y. It's no big deal.
Okay. All right. Kind of got it. I'm trying to figure out how to ask what I want to ask.
Well, just spit it out. He's a big boy.
No, I get all that.
You like gladiator movies?
So
Have you ever spent time in
He
a
does.
Turkish prison?
Banana hammocks.
I realize that this shouldn't matter. Okay. But putting it in terms of what actually goes on in the engine, is a given airflow always the same across the sensor at any throttle opening? Like, let's say you could move like your mass airflow frequency. Let's say it's 6,000. Is 6,000, 6,000, 6,000, no matter what, part throttle, half throttle, full throttle? Does it always behave the same? Or is there any difference in impact? I guess that would be, I'm kind of answering my own question. It would be as long
you're
as
asking how a hot wire mass airflow sensor works is what you're really asking.
well, yeah, I know how it works, but it would just seem to me that,
Well, no, here's the point. So different housings for the same hot wire type arrangement
mhm,
are more or less susceptible to reversion or backflow.
that's okay. Got it.
So if you have a wide open throttle at a low RPM, and specifically on a lower cylinder count engine, there's more time in between each intake valve event, right? And they're pretty intense because it's wide open throttle and there's no throttle blade to break up that wave going from the intake valve up the runner, through the plenum, out the throttle body, and through the zip tube to wherever the mass airflow sensor is. So you can hear it. It's noise. There's a positive and a negative to that wave, right? And the airflow tends to wash back and forth over the sensor. So the old LS1 sensor, where it's just the wire hung out in space, is really susceptible to backflow and reversion, and it doesn't know what direction the air is flowing. The newer Hitachi Elements 3 LS7.
Now, is that the one people refer to, not to interrupt, but that's the one people refer to as the card, right?
Yeah, the card or the slot. And 05 and up Mustang got those too. They were just analog instead of digital, although Ford switched over to digital eventually. It doesn't matter to me, but it's a torturous path, so the air can only go through the measurement element basically in one direction. So they're much less susceptible to backflow, although if you had big pulses, it would go forward through the sensor, back around the sensor, and then forward through the sensor again, theoretically. So you could get multiple measurements. And in those cases, that's where we'd much rather go to a speed density model. So GM has their dynamic airflow model, the speed density, VE, virtual VE, all that stuff. And Ford actually has a load with failed math table that they can call, and you can set it up so it uses that and just ignores the mass airflow sensor when you know you're giving it garbage data.
What's it called?
Load with failed math is it's going to be on the older stuff. The newer Ford stuff's all torque model, but go back to even Fox Body and SN95 and and it actually does wonders for making the car drive really nice if you could dial in the load with failed math table, which is why we showed it to people on our Ford tuning video. Like, hey, do this. It'll make your car drive nicer.
Okay.
But then the other thing is, guys like to put cold air kits on their cars, and they eliminate the restrictive factory inlet system.
Were you just doing air quotes?
Yeah.
You were, right?
Like,
Yeah, I saw it.
No.
You were too.
But they had the old LT1 Camaros had that big donkey dick hanging off the zip tube in between the throttle body and the mass.
Family show.
And
Yeah,
people just-
this guy, he's
off the rails.
off completely. Jeez.
And the problem is that's a Helmholtz resonator. It's a quarter wave resonator. It's meant to break up that giant waveform that's pulsing at the mass airflow sensor.
Right. Well, most of those things were actually put in the car when we talked. I mean, I think you and I had a brief conversation about that. We're talking about silencing the intake system. An audible noise is a frequency, and that would act on the meter.
Yes, and yes. There you go. You got it both. That's the 2 points right there. I'm done. I don't even know why I'm on the show.
All right. All right.
Sorry. Well,
Later.
see, you did such a good job teaching me some shit that it stuck.
No, I'm happy. You're learning. That's good. It's what I want to see. So, yeah, that's why those are there. And when guys eliminate those, they can introduce more noise, especially at the low end, to their mass airflow sensors. 6,000 RPM, wide open throttle, mass airflow sensors are awesome, right? But, off idle, tip in, they can be noisy and they can lie to you. You got to be careful. So that's where, is 2,000 hertz or 3,500 hertz. Is that the same everywhere? That's where you could get a little bit different. So if I'm not sure I'm getting a clean MAP signal and it's staying right in like one cell of the histogram while I'm recording it, if I'm not happy with that, trying to do that in, let's say, third gear at 1,500 RPM, then I'll downshift to second and go to higher RPM but lower throttle angle and see if I can still get a steady reading on that cell, at 3,500 hertz or whatever. Or I might go up to fifth gear and lug it and just, try a different speed load combination that is the same actual airflow, but try to get a steady frequency reading from the MAF on a GM or voltage on a Ford, right? And just get a good clean reading without the reversion.
Gotcha. Oh, okay. Understood.
And that, again, a load-bearing dyno makes that a hell of a lot easier than if you try and pick a steady throttle position on an inertial dyno, then you're, by definition, always accelerating if you're making any kind of positive torque, right? And you're not staying at that constant point.
Now, when you were doing, what is the term that was used for finding the correct ignition timing? There's a graphical term for what it looks like. I can't remember what that is.
Spark hook.
Yeah, spark hook. That's it.
Searching.
Spark hook. That's what it is. You were using an engine dyno. Could you perform this same procedure on a chassis dyno, or does it get too difficult?
No, you can. You want to try and eliminate all the errors in the measurement. So you want to, stick shift, it's a lot easier than an automatic, but even on automatic, if you can lock the converter, lock it into a certain gear so it's not going to, change on you. I've done it live in a class before. We lock the car, you do the manual override, lock it in third gear, lock the torque converter. You're not doing it at super high load usually. You're just doing it to prove a point.
Mm-hmm.
Hey, there is an optimal spark angle for this airflow. So we don't look at throttle angle, but we do try and normalize, make sure we're at the same RPM, same MAP, same intake temperature, which should come out as the same gram per cylinder. And we might verify that it's the same MAF frequency. And we say, okay, well, that's the same conditions, right? Still lambda 1. And I'm going to intentionally slew the spark. So the older ones where we have the bidirectional control, it's really nice because you can just say, okay, well, take 6 degrees out. Now take 8 degrees out. Now take 10 degrees, right? And the bidirectional control lets you do that. And you can just look at wheel torque on the dyno and it'll tell you. And you write it down on a notepad or Excel sheet or whatever, and there you go. I mean, it'd be really cool as if your dyno's got the ability to plot A versus B. Like I think Andre at HPA did a kind of slick setup where he had it outputting dyno torque and ignition angle into the computer simultaneously, and it just drew it in real time, which is cool. It's easier with some standalones. So standalones is a lot easier to slew the timing than a lot of OE controllers, but the bidirectional made it easy on that particular ECU.
Gotcha.
So, I mean, you can do it on chassis rolls. It's just, you got to have the discipline to say, no, we're really at the same conditions and we're not changing anything as we go. The tires aren't getting hotter on, run 1 versus run 6. There's more variables. So it's always a game of trying to reduce the variables.
All right.
But you would be close enough, no? I mean, you're probably not to certify for what you do, but it would still be a very good barometer, even if you were. I mean,
MBT is MBT. It
always.
is.
Sure.
So how you got it doesn't really matter. I mean, if you retard the timing and it loses torque, that's bad. If you overspark it and it knocks, that's really bad. If you add timing and it didn't add torque, why bother? So that's the short answer on timing.
All right. Let's get into dynos, because after specifically, and again, Greg and I talked about it today. I didn't want this to be an infomercial for his stuff, but if you're really interested,
he did.
Yeah. Well, no. I mean, of same agreement.
Yeah.
If you're interested in how this really works, like what really goes on at the core level and why you do the things you do, and some of what we're talking about here, they are in all this information's in his DVDs. And Jeff, like I said, I gave them to you and you spend time watching them. And I mean, you have to, it had to help out immensely from where you started.
Yes.
But, but after Jeff actually watched them, he says, man, we need a dyno. We need a dyno we can have access to. So let's talk about the different types, different brakes and why and how? Like as a tuner, ideally, or a calibrator, excuse me, what would you like to have for a machine?
Unlimited budget, give me AC motors everywhere.
Okay.
But they're super expensive.
Sure. So not practical, but what is the benefit of the AC dyno?
Well, AC dyno can react almost instantly to any change. Right? And sized appropriately, they can do all your absorption. And the other really cool thing is that while they're doing absorption, they can actually put power back into your grid.
Okay.
So like at the Chrysler Tech Center, they get about 1/3 of their electricity to run the entire tech center from the dyno lab downstairs. And that includes the pilot plant, where they do forgings and castings and everything, all the office building for all engineering and all finance and all marketing and legal and everything. So, they got a lot of hot air they need electricity for. It just, it's kind of cool because you put power back on the grid. And AC motors can change speed very rapidly. They can also, the big one is they can apply torque to the engine in a negative direction. Right, so you can drive the engine or even the tires on a chassis dyno with the rolls. So you could be off throttle, zero pedal angle and 80 mile an hour, and the dyno keeps you going 80 mile an hour. If you want to see what it looks like transitioning in and out of D-cell fuel cut, it's kind of handy, right? Because it's like, what if I was going downhill? Well, we can simulate that, right? So that's, given the wish list, I mean, that's what I'd love to have.
How expensive are they? I'm just curious.
Retrofitting, I looked at this a little while ago, and retrofitting an existing eddy current with about 100 horse AC motor adds, I want to say about $90,000 to the cost of a chassis rolls on a performance dyno kind of thing.
That's it?
And that, but
let the dyno guys quote you that, but I mean, it's going to be, they plan on something in that ballpark. It's
right.
expensive, but the nice thing is you don't need 1,000 horsepower worth of electric machine on it, especially if you've already got an eddy brake on there, because the eddy brake can do 500-600 horsepower of absorption, and then you add another 100 horse of absorption or motoring from an AC motor, and now you're up to steady state 700 horsepower absorption steady state, right? And really, when we do our wide open throttle runs, we're still doing a sweep on the chassis rolls. We're not doing state at 7,000 RPM and 1,000 horse. Right? That's unrealistic.
Yeah, I would hope everybody listening understood that, like, when we're talking about some of this testing, we're not telling you to stop at every RPM and just hang out there and take a look. That's not.
No. Why? And the funny thing is, like, wide open throttle testing for me is like a small sliver of tuning a car. Even when I do high performance stuff, it's the kind of the footnote that's done about 75% along the way. Before I do wide open throttle, I've done tons of part throttle work, and I already have a really good idea of what the engine's probably going to do, and I just kind of extrapolate the curve upward. And then my first watt pass is confirmation that, oh yeah, it followed that curve.
Okay. All right, and then we get into the eddy brakes, which I guess are just essentially an electric brake from everything that I've seen.
Yeah, I mean, the most common application for them is locomotive brakes. Right? Trains use them to slow down. And so, trains only need them for negative torque. They put them on other cars other than the lead engine. And when you put an electric field around it, any relative motion results in drag. There's no torque at zero, but at very low RPM, you can generate tons and tons of negative torque. And then they have a certain amount of power that they can absorb. It's often thermally limited. So if you got a 500 horse eddy brake, it's 500 horsepower, but that's a ton of foot-pounds down at low RPM, or less up top, but still 500 horsepower. Right? And I mean, most of our steady state mapping, when we're doing part throttle, steady state, I mean, it's uncommon that I really need the absorber to be absorbing more than, 150 horsepower, kind of on the top end, maybe 200.
Well, I would imagine that these things work like electric motors. Like at stall, they have their highest torque number or resistive number, I guess is how it would be.
They need to come off zero to work. There has to be relative motion for an eddy
Right,
current
close
would
to
work.
stall. It's close to stall is what I was trying to say. Yeah.
Yeah. But yeah, generally speaking, once you're going 5 miles an hour, you can have all kinds of torque from an eddy,
Okay.
which is why they're really good at stalling diesels. If you know somebody, you got a chassis dyno with an eddy current brake, and some smart guy with a diesel says, "Oh, you can't," oh yeah, watch this, and you just dial down, speed control test, and you bring them down to about 5 mile an hour, and you get them under the point where his diesel can make torque anymore, right? Because he's under idle speed, and he's trying to do idle recovery, and the eddy current has 500 horse worth of capacity down there.
Mm-hmm.
It wins.
Okay, and I guess what makes these particular brakes what they are is their ability to reject heat, to remove the heat, handle the loading to make the magnetic field, and then remove the heat, correct?
Yeah. So an eddy current turns mechanical force into heat. It's a little bit of electricity in there. So electricity it pulled out of the wall also gets turned into heat, which is why the rotors on an eddy current look like a fan blade or like a brake rotor, right? They're trying to cool themselves. So one of the other things too is, oh, by the way, if you're plotting out a new dyno shop for yourself, then you want to try and have some ventilation around that eddy current so that it doesn't overtemp.
Okay.
So, having a fan that blows air in that general direction, or at least so they can radiate their heat out and about, is important, right? You don't want to touch it right after a dyno run because it might be pretty warm, depending on how much work you've been making it do. But keep in mind, usually when we do wide open throttle sweeps on an eddy current dyno, I don't like just doing X%, because that's not a real thing for me. I'll set it up to do road load.
Mm-hmm.
And for the typical Mustang Camaro kind of car, the road load horsepower, at let's go even stupid at like 200 miles an hour, assuming your dyno's rated for that. It's still, 700 horsepower, give or take. And so, if you've got 700 horsepower with the eddy current absorber, you could theoretically run steady state at road load at 200 mile an hour. But it'll generate a fair amount of heat doing that. So, but, when we do a fourth gear sweep and we're only going, like my Corvette fourth gear is, about 110 mile an hour up through about 130 mile an hour in the power band, it doesn't require 600 horsepower with a dyno, because the road load for that car, even at 130, 140 mile an hour, is not 600 horsepower, right? The fact that it makes 600 horsepower means it can continue accelerating over and above the road load.
Right.
So your road load is, really much lower. So, a single eddy current will usually fill the needs of most shops, even up to and including pretty darn fast race cars that are going, 200 or so.
Yeah. So when you're looking at the
bearings rated for it,
right, when you're looking at the rating of one of these dynos, if they say they're capable of 1,500 or 800 or whatever the number may be, that would be effectively if you were trying to steady state.
Yeah, there's two things. One is, there's a steady state limit, and that's a function of the brake. So the brake might be only good for 500 or 600, and that's it. However, it can measure beyond that, because the brake just transmits force at a distance to a load cell. And so you've got torque times speed plus inertial effects equals power input to the system. And so you can measure extra power because it results in additional acceleration. So even with a 300-400 horse eddy brake, you could measure 1,000 theoretically, as long as you're not going to bend or yield the moment arm or hurt the load cell that's measuring the force being put into the system. And as long as the bearings are rated to keep rotating at the tire speed that you're going to be running at the end of that run, it should be able to measure large numbers as long as the software doesn't run out of fingers and the counter.
So, I have a question. The eddy brake, I guess, comes in the hub style and the roller style, correct?
Yeah, it's just a brake. So you're talking hub versus rollers is just how we attach it to the car.
Okay.
So you attach something to the car, and then what are we going to absorb it to? So the hub style isn't necessarily an eddy, and an eddy's not necessarily one or the other. It just, the older hub ones, like the Dynapacks, were hydraulic. And even like Superflow or Rototest has a hydraulic one as well. And, I've worked on stuff at GM when I was doing the Volt. We had 4 AC machines, one hooked up to each wheel of the car.
Oh, geez, that's got to be pricey.
Probably
Yeah.
a little bit. So what's your preference? Do you like the rollers or do you like the hub style?
I still kind of like rollers. I mean, the hubs are nice. You can push them out of the way if you have a space limitation, but it's always a rash getting the wheels unbolted and bolting that up and going back and forth. And so for a lot of street car, I do a lot of high performance emissions legal street car stuff. So unbolting and bolting up the hubs and putting these things in close proximity to nice paint jobs on cars, I kind of don't like that. Things get a little cramped. Sometimes the door won't clear the hub, so now you're locked in the car. It's nonsense.
Oh yeah, I didn't think about that. I guess depending on the configuration of the car, where the absorber is set in relation to the door, you might get kind of stuck. Yeah, I get it.
I like the hub idea.
It's not bad. I won't crap on it. I like rollers, and in fact, given my choice, if I'm building my own emissions and performance lab, I'll just get an all-wheel drive link with probably one good eddy brake and maybe a small AC motor attached to it as well, so I can do negative torques and coast downs the right way.
All right, Jeff, you just dynoed your car at a friend of yours' place, right?
Yes.
And that was on what?
Hub. We used a Dynacom DC pod, I think it's called.
Yeah.
And,
Dynacom.
Yeah, we know a girl from there, don't we?
Do we?
I think so.
I think we might.
She doesn't call us anymore.
No.
We may have met.
But were you there like during the actual, like for the whole thing?
Yes.
Like start to finish?
Yes, I was, watching them hook it up and everything. It's a little bit of work.
Yeah, I was going to ask you, what was your experience to get the thing on there?
I mean, you got to drag them out. You jack up the car and you got to, move it around and adjust and stuff. But once it's hooked up,
Is it really any more though than strapping? Finding places to strap in and not hook the body and all that nonsense. I mean, did it take much longer?
Yes.
Did it? Okay.
At least a good 20 minutes, 25 minutes longer.
Okay.
Because I've done plenty of chassis dyno sessions as well.
But you see, like
the only other thing too with hub dynos is there's basically no inertia, right? Unless they intentionally add weight plates to it. So you go from a stop to wow, right on up to whatever RPM immediately, right now. And if you're trying to do a replication of something like, let's say you're driving the car on the street and you said, hey, at 40 mile an hour, I felt this weird thing as it was doing the gear shift. And I'd like to replicate that in the controlled environment on the dyno again to try and troubleshoot that and find out what that is. The hubs just pretty much won't let you do it because there's no inertia. It's not like driving the car on the road. And although they can do great steady state work and give you super, super precise steady state measurements, and they can absorb all kinds of power for watt runs, they don't do really well replicating road load.
Even though this particular one is a eddy.
Well, yeah, that's what he's talking about.
Oh, I'm not a dyno guy.
Yeah, it's no, but now is the response to these things, like you brought up a couple of times, like AC responds faster. I've never used one of these machines with a brake with an eddy, so I don't know how the response is. Like, can you like you don't have that level of control, like I would imagine. Like it's not an instantaneous thing with an eddy.
Well, no, you can have an eddy brake on hubs, right? And, Dynacom, I'm sure, sells them that way. And people who license the technology. So, I mean, you can get an instantaneous reaction torque on a hub dyno. No question. The problem is that, like, can be than what you would really want. And they don't necessarily give you the curve of reaction force exactly equal to equivalent road speed.
Okay. Yeah, because like that's what I was trying to get at, because it would seem to me that the eddy current brake is an electric brake, that would kind of get into dyno software, like how the controller worked. Like you would.
Yeah, I mean, they could theoretically put it in the software, and I haven't played with Quantum Dynocom enough on a hub to see their latest hub with their latest software in road load to see how that feels versus driving the car on the street.
Okay.
Right. You know, in theory, it's possible to get there on all positive torques, but then the moment you let off, it's going to slow down a bunch because there's no inertia to keep things moving.
Right. But now let's talk about from the safety perspective. I imagine horrific things could go wrong with a hub dyno as well. But I mean, we've all seen YouTube videos, cars coming off, tires letting go. I mean, I watched some guy on YouTube, probably everybody's seen it because you get in that YouTube loop, and there's a guy with a Mustang who like teared all his shit to hell when the back tires went bad, or a tire went bad.
Yeah, one tire. Yep.
Well, I think, if you go back and look at what happened on that video, they were pulling that car in fifth gear, and the road speed that they were running at was pretty high, right? The tire speed was really high. So the shaft RPM on those small dual cradle rolls was really high. And so it was a failure of the bearings on the rolls, not the tire itself.
Oh, so that tire didn't actually go bad first? The bearing went bad?
It's chicken or the egg at that point, but both of them were, the bearings were certainly probably well past their rated speed. And so I'm not surprised when it's like, would you run a prop shaft, a drive shaft beyond its rated speed? Because it's the same thing. It turns into a jump rope.
Mm-hmm.
Mike would.
Yeah.
Yeah.
Anyway.
When Mike ran that little motorcycle motor like that, he wasn't getting anywhere near any of that shit.
Yeah, I hear you.
That was right at the end. Our Superflow brake, I think, was rated for 10,000, and I think the rating of 10,000 we surpassed. It was like 11.5, and I wasn't going near any of that shit. That's creepy stuff. The other thing that bothers me about the chassis dyno stuff, and I don't mean any disrespect to anybody that makes them, uses them, messes with them, it seems like that from the calibration perspective, like talking about what you actually have to do to calibrate, fantastic tool. But it seems like in the power measurement side, like to come back and do A to B to A to B and to really do testing, like I have seen very few, if any, people that we like on an engine dyno, oil temperature. Extremely important aspect of while you're dynoing.
Mm-hmm.
Well, now you've got a whole car. Now you've got engine temp, trans temp, rear temp, how the tires are behaving, air pressures. It seems like that it's wildly crazy.
Unless you take the time to, a NASCAR shop will treat it just like an engine dyno.
Yeah.
Yeah, we've done that on chassis rolls before, and I mean, keep in mind, that's how you play the game if you're really interested in playing that game.
That's right.
More power numbers.
No. Hold on. I got to interrupt there. Hold on, calibrator guy, because I've heard that used a lot. Well, you're racing a dyno. No, you're not racing a dyno, because if you're going to do 10 camshaft changes in a comp eliminator motor and you need to do this, you're not going to probably do it all in one day. And you got to go back the next day and everything's got to be really nice.
Sure.
But there's
he just meant play the game like play the game.
Trying to make the hit your absolute best dyno number. We're gonna make a little change. We're gonna make another pull.
Well, no, he's saying happy. Owners want happy numbers. So everybody learns how to play the game.
I'm always looking at it from a data perspective.
I worked for a certain prominent supercharger company at one point, right? And they were always, let's make sure our phase 2 makes X horsepower. And we went in and it made, X minus 40. And, the vice president's like, no, you gotta do, it's gotta make more. I'm like, so, I mean, it starts to become an ethical dilemma for me as an engineer, because I'm like, well, it's not really fair if I super chill the intercooler, but yet run it with hot oil and a hot differential and make sure the bearings in the dyno are good and loose and lubed up this run versus the baseline. And, there's games you play and they can add up to another 20, 30 horsepower really quick.
Mm-hmm.
And you can fool yourself into thinking you're making more power, but in reality, you just had sloppy data collection.
Yeah, and that was my point. I said it like a retard because what I was trying to say is that now you have, political. Come on, man. No offense, Ted.
Not taken.
We were like when you put the entire car, the entire vehicle into this. I mean, now you have a whole nother set of variables that you have to watch. There's much more than if the engine itself is on a dyno. I mean, and again, I'm not picking on anybody that uses chassis dynos. I'm not saying they don't have a purpose, and I'm not saying they're not great for getting this. But like he talked about the temperature and the state of, say, the rollers and the roller bearings and everything else. This is like guys that I can't tell you how many times I've been someplace, and they're going to make a change on a motor. They're going to pop another carburetor on, or they're going to do something. They take a little bit of time dicking around, and they go back, they make the first hit, bam. Oh, look, that's down 10. No, you lost 30 degrees oil temperature. It goes fast. So it just, for me, it always seemed like the chassis dyno, there's just so many variables to chase around to make sure they're the same. If you're trying to do productive.
It just matters how much time you want to put into the, I don't know, the etiquette of.
I guess so.
Yeah, the best guys I worked with on that were like the SECA World Challenges because they're not in a hurry, right? They say, well, let's just do the testing right, make sure it's really a game. And so I worked with a couple different or World Challenge team. They were, they're willing to say, okay, well, let's check our oil temps and let's check this, like that. Sure, because if there's 5 those guys. Right? And we're testing airbox A versus airbox B when they both have to breathe through a restrictor.
Exactly.
So if we can squeak out in a restrictor class, if we can squeak out another 5 horsepower, it's a big deal for the driver.
We were all thinking that. Or we can just float some nitrous into the room and fix it all.
Oh, yeah.
I know people that have done that.
Ghetto fogging?
Same.
Ghetto fogging. Never heard that phrase before, but yeah.
Yeah.
No, but the difference between those people, Greg, and we didn't hear most of what you said, but the difference between those people and the people that do it for money is the people.
Hold on. I just got to realize something. We never told him his phone was getting bad. We just let him.
Well, the whole night it's been that way.
Yeah,
we haven't told them.
Yeah, well, I mean, because
Great.
it goes and it clears up.
It's
But if there was something that we had to go back over, we go back over.
Mike will fix it. Mike's going to insert Tad's voice wherever you're blank.
Oh, boy.
So it's okay. We'll write shit in. So don't worry about it, Greg. No, but
Sorry, I need a stunt double.
yeah, we got one for you.
Bad choice. Definitely better standards.
But no, your point. We did get most of your points, and your points are solid. Those people actually want to know, so they put the time in. The guys that have to make a number or just want to see a number for their customer. I don't want to say they care less because of course they care, but
well, the unfortunate part is out of all this, you could get 5 different people, give them 5 motors that are identical. They all make the same power, and the one guy is going to go faster than the other guys because he's better with the car. So I know a lot of shops. Now, we never did this. We told you what it was, like it or not. I mean, like sometimes we had to tell a customer, hey, look, man, this one's down 7, from your best super stock piece, or down, 8 foot-pounds of torque. We can't find it. Don't know where it is. It's missing. Maybe second time around, we'll hone it and it'll get better. Who knows?
Yep.
But with a lot of these people, I understand appeasing the customer, but I came from a different world. We were always looking, to make improvements. We weren't just, it wasn't a product that we just handed a customer. You know what I mean?
Yep, I do.
It was research.
I do. Yep.
Now, we never talked about water stuff, Greg. I mean, are there actually water brake chassis dynos?
Yeah, I've seen them before. You can run, keep in mind, it's just a brake, but you just take the eddy current chunk out and you put a water brake, just like, an old Superflow 901, right? And you just put some sort of fluid through a turbine and a stator that creates resistance, right? And that resistance is a reaction torque. And if you open or close the orifice, you get more or less reaction torque, right?
Mm-hmm.
So you're just opening and closing a valve instead of adding or subtracting current through an electromagnet.
Yeah,
The result is, you still put it on a pivoting thing with a fixed arm and a load cell so it can measure force at a distance, which is torque. And so it could theoretically be a water break on a chassis rolls. It wouldn't surprise me in the least.
Yeah, I just never saw one of those, and like coming from me thinking about it, that there happen to be tanks buried in the ground here for water.
They're so common now. Why would you bother?
Yeah.
No benefit for it.
No.
So, Fireman Jeff,
Yes.
you're the most recent one to watch the Banish trilogy. Do you have any questions or pointers for him?
Pointers?
The pointers part was a joke.
Yes, I know. No, actually, I
Well, never
don't have
ceases
any
to amaze me
questions.
how dumb I used to be. So.
No, actually, I found them to be quite informative, and from someone who has absolutely no tuning background at all. I'm sorry, calibrating background at all. I learned a lot. I can follow along with the conversation now.
And I mean, more than anything, like, you're kind of saying you didn't have any background at all. You know how all this works. I mean, this is how to get to, like, you've looked at HP tuners, you've looked at all the different aspects of it, but this is actually knowing how to populate the areas with the data that we need. And that's why I was very impressed with this overall as a package. I thought it was really good. And when I gave it to Jeff, I said, look, you're going to learn an awful lot here because this is, and you're going to have to go through it a few times.
I mean, just thinking about when we first looked at HP tuners, and I was looking at all those boxes and grids and, menus and everything else, I had no idea what I was looking at at all.
But now you understand
yes.
that, like, the fuel injector data is critical as to why. That goes hand in hand with mass air data.
Yes.
Because everything that it does from all those, I guess, Greg, how did you explain that the fuel is your main item? Like, you need to know that, like what you're putting in?
Well, I mean, there's too many variables around a fuel injector to try and solve them all on a running engine. You got one equation and three unknowns. So, if the fueling's not right, let's assume your airflow was perfect. And your mass airflow sensor was a factory sensor in a factory box, and it was a factory engine, and you trust that the volumetric efficiency is exactly what GM said it is, but you've got some unknown set of injectors. And you go, well, I'm rich at idle. Okay, so are you rich because the linear flow rate is too high? Or are you rich because the offset is wrong? Or are you rich because the short pulse adder correction for the nonlinearity is incorrect?
Mm-hmm.
Right? All three of those are in play simultaneously, and you have one equation of X airflow, and Y fuel flow equals Z lambda, right? And even if you said airflow was perfect, you've got three things that could screw up the fuel flow, and you don't know which of the three to adjust. And then you go to the internet, and they'll give you village wisdom on how I know it's got to be this one, right? And the problem is, like, even if you put an accelerometer on the injector and you put a scope on it and look at the current trace, like, well, yeah, you can find where the needle opens. But the physics of how a fuel injector works is not, the needle opening is not the offset. Closing delay minus closing delay is an offset. So really the way to get that data is to go plot it. And so you kind of got to take the injectors off the bench. Bosch and Continental and Enzo do before they sell injectors to the OEMs. And Paul does it at Injector Dynamics before he sells his high flow injectors to people. And he says, here's what the curve is for this injector at this voltage at this pressure. And here's how we represent it in those terms for a GM or a Ford or a standalone or whatever. And once you put that in, then you have the confidence to never touch that again.
Yeah.
Right? If I ask for 10 milligrams of fuel, I get 10 milligrams. Right? There's no guesswork on that. Now, if my air-fuel ratio is wrong, I can safely assume that either my wideband's garbage, which is why I use good widebands, or the airflow must be different than the stock airflow, and I have to recharacterize that.
Mm-hmm. Now, and like
So
this
I
is
do one of those models at a time.
right. That's why I brought that up to Jeff, because when he had to change his injectors over to a set of IDs, there was the whole I was trying to bring that point up because that's one variable that you actually have a real measured amount. Like you can just put this in, and then that's right. You know what the effect is if you ask for that much fuel, like he said. But then once you have that stabilized, the tuning, just doing the airflow model, to me, that makes it very easy.
Yes.
like I said, I don't think anybody could go wrong watching these videos. I mean, for sure. And matter of fact, Tom was supposed to check them out, but we just didn't get around to doing it. He was away and all kinds of stuff.
Yep.
All right.
Yeah, and that's why Paul's been so successful is he's been able to tell people, look here, put this data in with my fuel injector.
People are asking what phone carrier you got.
I don't know, whatever the hell sells. It's Chrysler's. You want me to call it from the other phone?
No, it comes and goes. It's unpredictable, but it's not terrible. We've had people that were worse. Don't sweat it.
No, we haven't.
Come on, man.
Yeah, we
I got to make this guy feel.
All right.
No, hang on. You know what? Give me 10 seconds here. I'll fix this.
You gonna calibrate it?
Oh,
Yeah.
I'm going to calibrate
Newman.
it here. Hang on 1 second.
Sorry, Jeff.
Oh,
calibrating in process.
Hold on. I didn't realize he was actually calling. Hello.
Hey.
Oh,
We're
wow.
on Verizon.
Yeah, it's better.
Calibration.
We can hear you now, as they say.
Oh,
Good. You hear me now?
great.
It really, Greg, listen, don't be that worried about it. It really wasn't that bad. I mean, and with cell phones today, I think everybody just knows that there's going to be fuck ups and you just sit there and wait for it to clear up. So it's not a big deal. The points of everything got across just fine.
Hot potato with the cell phones, whatever. But yeah, so I don't know if I got my point. The reason why Paul's been successful is that, his data is correct, right? And so now other manufacturers are starting to take heed and they realize that smart customers who know how to tune now are telling them, hey, I can't use your injectors if you don't tell me what comes out of them. And so we're trying to, get the industry kind of up to speed and say, oh, yeah, we should probably know what our injectors really do. And, some of the injector manufacturers are saying they have it, and some of them actually have it.
Mm-hmm. Well, and
it's funny to watch it from the outside because I don't have a dog in this fight.
Right. And I completely get that. But what makes this really nice is like, look, the displacement of your engine. It's bore, it's stroke, everything. I mean, the more variables you can take out of the equation, the better off you are. And that was probably more than anything what I took away, that if you have that piece of the equation incorrect, just about everything else you're doing from there is going to be whacked. It's really.
Yeah. And it gets worse. So now, we're filming the Gen 5 DI GM stuff, right? And guys used to get away with, I'll just force it to mass mode, and I use these injectors because I got a deal on them, and I kind of made it work, and it's a stick shift, so it doesn't matter. Well, now all the DI stuff is torque-based throttle control, and the number one input to the torque model is grams per cylinder. And if you created your gram per cylinder estimate based on garbage injector data, guess what? Your gram per cylinder air is garbage, and your torque is garbage, and your drive quality is garbage. And oh, by the way, the transmission just ate itself.
So this kind of goes hand in hand with what Howard was saying the other day, that these newer, later generations of computer are going to separate out a lot of people from this.
Yeah, it just means you can't take the shortcuts anymore. You have to do the calibration faithfully. And, there's no excuse for putting in a couple hours of steady state mapping time to get that stuff right.
Okay. Well, duly noted.
You'll never fix it later.
We need a steady state dyno here at Power and Speed so we can continue our education.
Yes.
And we'll
you going to make that happen?
They're like boats. You get a friend with one.
Yeah. Well, I got two problems. I ain't got a boat and I ain't got any friends. So it really doesn't matter.
Me and Fireman Jeff are going to get a friend with one, Mike.
I just don't have a boat.
Yeah, that's what's going to
work. Yeah.
Now we're gonna. I've been looking, like your friend. He got that set of pods for like next to nothing, wasn't it?
Yeah, but that was lucky. One of those once in a lifetime deals. I've been looking ever since, and
because I peruse all over the place looking to see if just the right thing comes up. Needs work. Need some TLC. Yeah, I'm full of that. I can handle that if it was required. Yeah. I can't see spending $70 for a toy. That's the problem.
No, we all agree with
Not going to do this for a living. This is a Mike thing.
Wait a minute. What about that thing in the garage? Isn't that a toy?
Yeah, but that toy, I can go to Sonic and get a soda.
Very true.
This one just sits in the garage.
Wow.
Yeah, there's no reason for that.
That's 30 grand buys a lot of ski boat.
Yeah, but I mean, like the dyno price, I think by the time you option stuff and everything, you get right up there real quick.
You'd get Mike on a ski boat. Yeah.
No, not how you can't get Mike out of his house, let alone on a ski boat. And I'm not a big fan of
water, shorts. skis,
boats.
Boats are fun.
Boats are not fun.
They
That's
are
like-
fun.
There's
They are.
alligators in lake up here in Michigan.
It's kind of like airplanes, man. You know, you can't pull over and get out. If you got to get out of a boat and you ain't nowhere near land, you can sink. You got to.
Oh, you can.
And you
shore
can
from
swim
everywhere on that
too.
lake.
That's the real him.
Yeah.
Nah, I'm fine.
Come on, we'll teach you how to swim.
Terra firma. I can swim.
Get his little floaties.
Yeah.
Swimmies.
So you
Swimmies.
say you can't pull over and get out. What's diving?
Oh, sure. Can you live there until somebody comes to pick your ass up, like, say, 20 hours later? No.
Oh, you didn't watch The Shape of Water?
You guys are a mess. I'm happy on good old solid ground.
Terra firma.
Makes me happy. I mean, look, airplane rides, got to do it. We got to go someplace.
Hey, you know they put race engines in boats too, right?
Hell yes.
Mhm.
Yeah, you know, I got to tell you, that's the other thing. That did I tell a story on here about my friend Rich
With the hydro or no?
when I went to go see him in Georgia?
No.
Okay. My friend Rich moved to Georgia. We went out of this boat, and I don't know what it was, but I think it was like a catamaran style boat, and the thing was extremely fast.
How
And-
fast was it?
Was like 120 something.
On the
Nuts.
water.
Oh, that's fast.
Yeah. And this was it. And I mean, you know, Rich listens. I'm sure at some point he'll correct me on this if I got it wrong. But the guy I was like, wow. I said, you know, how fast were we going? And the guy, you know, answered and said, yeah, that's the fastest I've had this thing. I was like, when'd you get it? It's like, not that long ago. Now I've seen all the YouTube shit of stuff like this blowing over backwards and
Yeah,
everything. I'm like,
yeah, everybody
this
dying.
is why I
Yeah.
don't do this.
Mogul wants to know if you like trains.
No, I don't like
Yeah.
trains. That was that movie, Dirty Harry, Dirty Mary,
Yeah,
Crazy
yeah.
Larry, whatever the fuck.
God
Yeah,
almighty.
that was
That's why you don't like trains?
childhood trauma, man.
Rich, you had to know that.
Childhood trauma. I can't help it.
For fuck's sakes. Don't try to cross in front of the train. You'll be fine.
They tried to and they didn't make it.
He's a special cat, ain't he?
Yes.
Got some hangups.
Just a few.
So you guys ran right out of dyno questions, huh?
Yeah,
How
we're
you can screw it up?
dynoed out.
Like ventilation. Ventilation. Give me 1 second on ventilation, because that's the thing that everybody tends to botch up.
Mhm.
Everybody just throws a dyno next to an open door somewhere, right? And that ventilation is what makes or breaks a dyno cell and a dyno shop, in my opinion. Right? If you look at Howard's place when you guys go down there, you'll be amazed. It's pretty good. He does it right. But I mean, you can get EGR from the tailpipe right back to the air filter, right? And that will certainly change your power number, because it's not 20% oxygen going into the engine anymore. It'll be something much lower. Right? And oh, by the way, the operator will get a headache and die of CO poisoning eventually. But it just it hurts your consistency, it hurts your power numbers, and oh, by the way, it's hard to cool the engine when you don't have airflow.
Yeah.
That's one of the things that I keep telling shop owners, like, it is impossible to have too much ventilation.
Now, I mean,
Like, please add more.
what we had at the old places, we had air coming from a couple different areas to make sure that we accomplished what we wanted to. First, you wanted to wash the motor with air. Like, in other words, you wanted air to go across the motor. So, like, if there was header leaks, crankcase breathing, whatever. Same thing in a dyno, like in a cell dyno for, say, a car. Do you want air to pass over the whole vehicle to keep everything going out the back? Like, do you ventilate the whole deal?
Greg?
Well, I like to ventilate the whole room. And so, yeah, I mean, I'm going to have enough extraction from the room that it greatly exceeds the exhaust capability of the engine itself. Right? So probably about 5 to 10 to 1 at least on extraction capability, because you want to dilute the exhaust before it goes out. And, if you're not going to couple something right around the tailpipe, which is just about impossible on a lot of cars.
Well, and what I was trying to ask is that, like, I know you would direct air at, say, the radiator, intercooler, what have you. But do you also have essentially a sweep system, or do these guys just normally just extract whatever is left from cooling out the back? Like, in other words, there a front fan, back fan, and cooling fans, or?
Well, you've got fans blowing on the radiator and the air cooler stack. Like, I love using lots and lots of the Home Depot carpet dryer fans to direct airflow, because you can direct it right at the intercooler, right at the radiator, underneath the car, you can direct them right at the catalytic converters, or if your prop shaft is near your exhaust, and you don't want your carbon prop shaft to have the glue delaminate because it was too close to your exhaust that you were running for an hour. Right? There's all kinds of interesting failure modes you can get. So yeah, we want to blow on things, and then all of that warm air coming off of those things can mix with the exhaust on the way out the back of the cell.
Okay.
Right. So you have an extraction fan for everything, and then you have these other smaller fans that direct air at things that need cooling.
You know, you really see how important the ventilation side of it is when you look at the cup shops. I remember telling you about I told Mike long ago, you know, I've been in a couple of them, and, you know, they go as far as they have the weighted vent doors to keep the pressure in the room, you know, the same, but still have enough ventilation. And it's really, really impressive what they do. They spend a ton on their rooms.
Yeah, and without spending a lot of money, I mean, even if you're up here in Michigan in the winter, I'd rather have the Dyno Lab be cold than be improperly ventilated.
Mm-hmm.
So just open the door on the other end of the shop, make sure the airflow is always coming in fresh from one side and going out bad on the other side, which is behind the car. Okay, so the air is always going in one direction, and you have enough capability to exchange the room often enough that there's no way you would be breathing exhaust.
Any of the place you ever go to, like, do they actually have like a manometer to see if they've essentially pulled all the air out of the room, like they're actually running in a depression?
Well, I mean, any good dyno shop should have a weather station right there, right? So, I mean, a lot of them should have barrel correction right on the dyno. So you're doing SAE correction on your power numbers. Well, it should get a barrel reading.
Oh yeah, I get all that, but we're talking about an instantaneous change. You know, closed throttle to wide. I mean, because like that was something that we had to make sure we had right in the test cell. I mean, we had a manometer. You know.
Yeah, I mean, so engine dynos, it gets worse because you got a smaller volume in the room, and so the volume that the engine can ingest more closely matches the volume of the room versus a shop. In a vehicle, you know, even a vehicle bay, it's harder to evacuate all of that through an engine than it would be a typical engine dyno cell.
Okay.
Right. So that's one of the nice things about being in a chassis dyno environment is that the environment itself is bigger. So it's hard to rarefy. It's hard to pull the barrow down in those applications. You know, your exhaust fan might do it if you weren't allowing makeup air from the other side of the room. You know, you didn't have the door open or whatever, right? But generally speaking, you should be okay. And I'd rather just pull cold Michigan winter air into the shop and have people bitch about it's cold than have inadequate ventilation.
Okay. All right.
And then, oh, by the way, you just got to remember, I tuned this thing when it was really cold. And so when it gets warm out, I might not be able to run as much spark.
You know, there's just one question about the dyno calibration. I think I might have asked you this directly, but does GM pick like standard, like what they would consider like a standard or an SAE standard for temperature when they do all these calibrations? Because when you look at like
SAE picks it for them.
Yeah, because when you, that's what I mean, they use an actual SAE number. They use SAE standard, because when you look at all the calibrations of the car at like 60 degrees or so, all that's zero. You know, so that's
not a coincidence.
Okay, well then, honestly, if you're a calibrator and you're going to tune a guy's car and it happens to be 40 degrees outside, how do you do it backwards?
So ideally, you would tune it in the nominal condition. However, things like spark adder versus charge temp. Somebody at GM got paid for 3 years of their life to make sure that table's pretty close.
Mm-hmm.
And if you're using a very similar combustion system, I would argue that compensation is probably pretty darn close to what you're going to want, right? If it gets hotter, it pulls timing. If it gets colder, it puts it back in. Okay, and you might not be on the 0 point of that sliding scale because you might be testing in January or you might be testing in August, but have faith that part's probably not the problem. I mean, fundamentally, we added a supercharger. Oh, geez, we're way over here, and we're way further into the speed load map than we ever were before. Let's just tune the base map and have faith that the temp adder is probably pretty close to reality. I see so many guys in the forum saying, "Oh, well, the temp adder, when it heat soaks, it pulls all my timing." like, well, duh. It's already warm. It's got a running start towards combustion, right? You don't need to lead it as much. And if you let it cool off, it would put the timing right back in, and that would be appropriate. Or you could zero that out, pretend it doesn't exist, and then the car that you tuned in August, which is probably safe, if you go race it end of the season here in Michigan, late October or something, and everyone runs 2 mile an hour faster than you because they've got extra timing in it that they could tolerate fine without any knock, but you don't because you zeroed out the table because you're smarter than GM.
Right, and that's where I was going with this, that if people zeroed out their correction tables based on because they're testing or doing calibrating in a cold environment, then everything is skewed so like all the data that they've gotten, you've wasted.
Yeah, and then, oh, by the way, yeah, if you tuned it in a cold day, let's say even if you tuned it in, March, and you zeroed out the temp adder, and you made sure it was safe and it had knock margin today. But what happens if I take that car and power tour, and I'm down in the dirty south, and it's 105 degrees out, right? And I'm stuck, because I was in traffic getting into the venue, and so I was sitting on a 140-degree blacktop for 45 minutes before I decided to open it up and do a burnout leaving the car show, right? Like, I just want to wreck my Mustang. I don't want to break the engine, too.
Run over people.
Yeah.
Car will do it by itself.
Well, I've got a Mustang.
Okay. Well, that makes sense. I mean, I get it. But because I have seen, again, calibration videos on YouTube where guys will zero all this stuff out and then they'll do their calibration. And I
hope that video was free.
Well, yeah, most of the stuff on YouTube is, and I guess you get what you pay for.
Get what you pay for there, I guess. I don't know.
All right. I guess the only other thing, maybe safety, real quick. I mean, look, I've gone through this before. I've seen these things come off the dyno and stuff go wrong, and I know it's probably operator error.
99% of the time, it's preventable, right? Mm-hmm. I mean, every once in a while, poop happens, right? It just, shit happens. But, I mean, how you do your straps, don't put straps on anything that's moving. Don't put straps near anything that's hot. Look what direction your exhaust is pointed, and don't put anything in front of where that's pointed that might ever possibly get hot, melt, or be angry at you, right? If straps are going to have to be near things that are warm, then they should be coated or they should be made out of metal, like cables or chains. The only problem that you run into there is if you've got metal chains or cables or something and they touch, let's say, the exhaust system, the knock sensor might pick that up. I've seen that before. But other than that, yeah, you want to make sure the car is, there's no such thing as being too secure on the dyno with the car. So, I mean, you just want to make sure, the way that cars get stabilized on emissions testing versus high performance dyno testing is radically different. I was really, really, really nervous first time I saw how we test emissions vehicles, because they're not putting, anything more than maybe 100 horsepower into the dyno at any point on the test. And all they have is kind of wheel chocks in the front and a little side-to-side guide cable.
Yeah.
And that was it. It was scary. I'm like, oh my God, you guys trust that?
Well, I mean, part of what I saw, and I don't know what the proper way. Look, I know how you tie a car down in a trailer. You X them in the back. Mm-hmm. I've seen a lot of people that just have kind of straps running parallel to the sides of the car, just a pair of straps holding the car, and then the car walks side to side.
I've never seen that.
Yeah, most of them X them.
Every single test.
Strap straight back, you'll have some side to side, under tension, they'll be a little bit, but they're not that strong that way.
Right. And when I'm talking about when you look on YouTube, this is how you see things coming off the dyno. So I know a bunch of it is people being stupid. I mean, for sure.
There's plenty of that.
But keep in mind, too, what happens if one of those crisscross straps breaks or pops loose, right? Mm-hmm. Now you're pulling the car sideways. Mm-hmm. So there's also that, right? You got to make sure. And so even no matter how good we strap the car, I still like using wheel chocks on both front wheels if they're not moving, right? Because if you have a big cam in the car and it tends to buck and surge a lot, the wheel chocks almost do a better job of stabilizing the car under that kind of condition than the straps themselves. Mm-hmm. Because the straps have a little bit of stretch to them, and the wheel chocks are basically saying, nope, we're stopping here. Right? They can't, you could theoretically roll up over them, but that's what the straps keep you from doing.
Yep.
They do a lot to stabilize it. So when you're working on, stroker motors and big cams and funny shit like that, then, wheel chocks are your friend.
I remember
when half the time people screw up is taking the car on and off the dyno too, right? So they pop the straps loose and they go, oh crap, and the car's rolling backward and it's off the dyno. Oops.
The first thing that I ever saw on a roller type chassis dyno was one of the circle track cars. The guy was searching for a problem, and that thing, it's got a ton of suspension travel. I imagine it'd be like testing one of those sand buggy things. And that thing was a train wreck. Like when you got on the throttle, there was like all kinds of chassis movement, and it would get into an oscillation, and it was really that was a little disturbing to watch as well. I don't know what to do with that kind of stuff.
Cross your fingers.
Well, I mean, for one, you're going to try and secure the axle. If it's a solid axle, you're going to try and secure that fore and aft with straps first, and then put straps on the body that kind of hold the body in place. But they've got so much anti-squat built into the suspension that they're trying to lift the chassis every time you apply positive torque.
Yeah.
So, you got to make sure it can't move it such that it would steer.
All right. And then
up down is disconcerting. Steering is really bad.
Yeah.
And front drive cars are equally as bad that way too, right? Because you got a lot of front drive cars that want to torque steer.
Yeah, there's plenty of them coming off dynos on YouTube.
Yeah, actually, I've seen the more I think about that, that's a lot of what comes off. Like the things going back and forth, side to side, and there's a whole bunch of people. I've seen people where they're holding them. They've got their hands on the fenders. Like, you guys are idiots.
Genius, yeah.
Oh, you got to get one fat guy sitting in the trunk to give him traction too, right?
I've seen that too.
Yep.
Not a chance would I ever be doing that.
No.
Wow.
No. You don't want to volunteer for that one?
I'll do it.
You remember that Shelby I had?
Yeah.
I found dyno videos of my car on YouTube, and 2 guys sat in the trunk because it was spinning the tires on the dyno.
That's just retarded. I can't imagine. Well, I mean, I guess as you get older, you get a little more scared. Okay. And then I guess typical safety stuff like that we always had. Fire suppression,
Oh, yeah. Does your fire extinguisher work? When's the last time you charged it or checked it or whatever?
In a shop, it should be tagged.
It's impossible to have too much of that. Like we would always have in the dyno cells, we would have Halon or Halotron ones instead of the ones that make the white, yellow, powdery mess of the car. If you have to ever discharge them, they're quadruple the price, but it's kind of nice when you're not paying to detail somebody's car over a single loose plug wire.
Mm-hmm. Yeah, actually, Jeff is a fireman. That's what he does.
My dad was a firefighter too. So yeah,
Halon in a shop.
Get to see a barbecue, and you're like, ooh, don't want to do that.
Oh yeah. Seen lots of those.
Hell on in the shop, you can't do that, right?
No.
If you put the fire out and kill everybody.
Yeah, exactly.
Yeah.
But and then by the way, don't let customers stand next to the dyno while it's running, right? Probably a bad idea. You'd be a bad guy once early on, but if you can, now technology is great because you can just put a camera in there and put a big screen TV in your waiting room and say, watch it from here. And they go, oh yeah, cool.
Yeah.
Then they don't have hearing protection, by the way, right? You'll go deaf in a dyno cell.
All right.
What about tire pressure?
Have some.
How much is too little?
Imagine it'd be the same amount you drive a car with.
Sure.
Well, you go to the track on a set of drag radials, you can go into the teens. Is that ideal to run on a dyno?
Okay, fair point.
Tom's fingering
tire
something on
pressure?
the...
Yeah.
I can barely hear him in the background. So
Yeah, I
sorry.
told Jeff to be assertive, but
I'm
we
sorry.
did.
I'll fix that. in
Tire
post.
pressure, yes. How important, or, is there a safe minimum pressure on the dyno?
treat the dyno like you're driving on the road, right? So, not the drag strip, the road. So what would you want to do on the road for a while? Right? Because it's all relative. You're not trying to cut a 60-foot on the dyno necessarily. You're trying to just get good, steady measurements and one good power sweep to measure everything. So, even with slicks or drag radials, I wouldn't be in a big hurry to run 10 psi instead of ET streets on the chassis rolls. I'd put a little bit more pressure in them just so that they're stable.
Mm-hmm.
That's it. Hub dyno.
Well,
in that case, it eliminates all of that question, right? That is one of the benefits of a hub, is you take that question mark away.
And the question mark at straps. I like the hub dyno.
I like it too. I watched a video on YouTube a guy testing with a hub dyno, and it was uneventful and easy, and it just looked much less chaotic.
Yep.
And that might be just me.
We could afford the 20 minutes.
Yeah. One last thing that I know that Jeff should have crossed his mind, but it crossed mine right now talking about it. Jeff has an issue with his particular car right now that since they've added additional power to it, it doesn't seem to want to behave as nicely with the transmission as it used to before. Now, I understand that this all goes back to calibration, but this is a question I'm going to ask you. Can you actually sort out trans stuff on a dyno? I mean, can you actually do it?
Yeah, sure. Why not? It's no different than driving on the road.
Okay.
If you have a dyno that can do road load, especially, then it should shift through the gears, accelerating on the dyno the same as it does on the street.
Okay.
If you've actually got road load.
Okay.
And, I've done that. So, if I want to troubleshoot drive quality issues in Michigan in January where there's snow on the ground and, ice and potholes and whatnot, like, well, let's just do it on the dyno. Let's just check it out.
Okay. Now, I mean, these things I know, and again, I can't ever picture a way that this could be done. Could you make a pass through the gears on a roller dyno, or would that kind of really have to be a hub dyno?
Like quarter-mile pass?
Yeah. Like, obviously not launch the car, I mean, not.
Oh, no, I've seen them launch it. And Mustang had cars doing it side by side on a trailer dyno outside of PRI back when they were in Orlando.
Really?
Yeah.
Absolutely, yeah.
DynoJet had
passes.
in the Ford booth. They did it at DynoJet.
So wait a minute. They got the cart like they're up on a trans brake and let it fly.
Yep.
Yeah.
Well, no trans brake. The ones I saw were stick shift cars.
Wow. Wait, whoa. Really?
Yeah. Yeah.
Oh, God.
Yep.
Yeah.
In the Ford booth at SEMA.
Wow.
Yep. True story.
Cool.
I wouldn't have thought you could have done that. I really wouldn't have.
Yeah. And it's in assuming the traction on the dyno matches the traction at the drag strip. So if you have a car that pretty much dead hooks and goes, you should end up with an almost identical lapse time.
Yeah.
If you did it right, there's a couple of ifs in there, but if you do that right, it'll probably fall in line.
Okay. Mike?
I don't want to go to the track anymore.
I'm kind of done. I need a dyno.
Yep.
Yeah.
Just for education and fun.
Well, we're going to have somebody on in the next couple of weeks, one of the dyno companies. Maybe we'll get a couple of them. Maybe we'll get them to come on and
Cage fight.
talk to each other. Yeah, that'd be cool, right?
Dyno drags.
Well, Greg, listen, it's been another good night. Everybody in the chat room has thoroughly enjoyed it, saying things like informative, really smart guy, lose the Obama phone.
Hey, come on, they paid back their debts. That's not an Obama phone anymore.
Yeah, I'm just, I didn't make that up.
It was. You didn't make it up. I saw it.
That was actually there. But listen, thanks for the time. Thanks for the info. You want to plug all your stuff? I mean, Mike.
Yeah, it's great being on the show with you guys. I appreciate it. Yeah, so Calibrated Success is the website, calibratedsuccess.com. Our partner is Detroit Technical Media, but if you look at my media page and say, where do I buy this DVD? If you just click on it, it says buy here right now. It'll take you over to our partner, Detroit Technical Media. Dave does a pretty good job of shipping them out lickety split. If you're super impatient, you can also go buy them from Summit Racing Equipment, or if you guys got an ATEC account, they'll probably give you some sort of discount. And they can get them at your door tomorrow morning, I'm sure, because it's Summit. We're working on more stuff. So, I mean, we got, a couple books on Amazon. We've got the GM Basic, the GM Advanced that you guys are watching. There's the Blu-ray that kind of applies to anything with spark plugs and fuel injectors. So it's both standalone and OEM stuff. I got a Ford disc out there for the older stuff. We're going to be doing Coyote and EcoBoost in the future. I just got to finish the GM Gen 5 stuff that we're filming right now.
Okay. And I can tell you that as a guy, see that my experience in this is so limited because I look at an E38 computer. It's the only thing I have to look at. I have no additional horsepower yet, although my power spirit here is probably
That's right.
Power spirit.
We'll talk about that.
Parrot M babies.
I have no experience other than the E38 and HP tuners. So for me, the first and the second, like in the GM series, were tremendous because it answered a ton of questions that I can't.
Well, the cool thing is GM didn't change their software very much over the years. So E38, if you can tune E38, you can do a 411 box, right? It's, you can do an E67 is almost identical, right? Don't get caught in the E whatever number. It's just GM strategy.
Right.
And really behind all that is you're learning the physics and you're applying it.
Mm-hmm. So, I mean, I would recommend...
Learned where those tables were in a Ford, you'd figure it out pretty quick.
Yeah, I'd recommend anyone that's getting into the GM side of this, if they really want to do it, if they want to take up this, hobby, or, even I guess if you do it for work, there's an awful lot of information to be learned here, and this is solid foundational stuff. I found it extremely informative, to say the very least.
Ditto.
So,
well, thanks.
No, no problem. Thank you.
That's kind of the goal. Is we want you to learn the what and the how and the why, not the just push this button.
And that's exactly the problem that I have, because when I ask people a specific question and they say, "Well, that's just what you do." No, I want to know how we got here so I know what to do if what you're telling me is fucking wrong. You have to know that. No.
Yeah, and I'd love it to be the point where you're a critical thinker and you go, no, this doesn't look right. Let me go back and see what I missed.
Right. Well, I'm good.
Yep. All right, man. Well, we'll do it again. We will. We appreciate you, and thank you very much for the time.
Yeah, I'm looking forward to the
Thanks, guys.
to the late
Good time,
model
always.
direct injected stuff. When you get that done, definitely let us know.
We were filming at 9:00 last night, so we're still working on it.
All right, fantastic.
All right, let us know, man.
All right.
We'll do.
See you, buddy. Thanks, Greg.
Thanks, Greg.
Take care.
Sweet.
Bye.
Super, super, super sharp dude.
Yeah.
I mean, and this, his perspective, and I know somebody I saw it roll by in the chat room, emissions. Yeah. But you got to understand where this guy learned what he learned. This is not a guy that was banging on a keyboard, tuning a car and saying, "Hey, I learned these little tricks to make it better." This is a guy that was, at the places that make these things that we drive every day.
Yeah.
That make them work nice. You turn the key. It doesn't matter if you're in Alaska, if you're in a desert, the things start and they run and they do everything they got to do. So I would put a lot of weight on his methodology. I really would. Me personally.
Same.
All right. So before we get out of here, should we talk about Power Spirit? Can't believe it really
Power
says
Spirit.
this. Can't believe it really says. Can we talk about this, or are they going to get mad?
Who's going to get mad?
The Power Spirit.
Spirits.
I don't know. They must be proud of it. They put it on. They cast it in.
Power Spirit.
Well, here's what's funny. Tom has a hook to get turbochargers at a good, and you said that this is a serious guy. Like certain components of this are particularly good, correct?
Yeah.
Yeah.
Yeah. Well, don't give away all of our secrets.
I'm not going to give away all of our secrets. What the fuck secret? But I can tell you this, that, man, these Chinese folks, they really got to work on naming.
I'm kidding. Man.
I swear to God, on the volute of this thing, it says Power Spirit. That's like...
And he swore that on the volute.
Yes. I mean...
He got it in.
Magic Wind. I mean, you can come up with all these different names for these things.
Does it
Well, it
have
probably
air goes in, happiness comes out?
Yeah, it could be shit like that.
It probably sounds really cool in Chinese.
Yeah. Yeah, but it
Or
must.
not.
Or not. But they got to hire some English people to just be like, no, man.
No,
These
man.
Americans will buy anything.
But I do finally, they just walked in today. I have a pair of turbos in my possession. So we're going to put
They're pretty damn nice too. You must admit.
yeah, I mean, I don't know enough about them. The first thing when I looked at it, I'm like, that's it?
Well,
Because it looks stupid.
they have been violated. I watched Tom.
I saw him
Yeah.
sticking his fingers in it and everything. I am just shocked at how small a package overall this is.
Yep.
And I guess because the turbo stuff that I've been around, like go to Anthony's shop and you look at
Well, you want with him. He's got what, 88 millimeter stuff?
well, no,
or-
you look at this big giant single was on a Mustang
Yeah.
and
Yep.
the exhaust housing is like the size of my head.
Yeah, they weigh 90 pounds. Yeah, that's legit.
So I mean, it's just I'm really looking forward to
what's
this.
he making?
You know that's the
4,000
name.
horsepower. So
You know that's the name of your Tahoe now, right?
What?
Power Spirit.
Power Spirit?
Spirit.
Great.
oh,
Don't tell Elizabeth Warren. That sounds a little Indian.
Yeah.
I think I think I'm going to put, now that it's getting warm out and, and look, again, my building's heated, but who the hell wants to roll around on a, cold garage floor and everything else? We're in a good position now. So I think I'm going to get started on this thing probably sooner rather than later. I got some headers that are like kind of a universal deal, but eyeballing it up as best I can. I think this will put me in a nice starting place.
Mm-hmm.
So I'd like to get this all done.
Yeah.
So yeah.
So let me know, man.
Project Todd. Oh yeah. Now listen, here's one thing I'll say about Jeff. He ain't afraid to work. This guy, motors in, out, knows everything off his car. I mean, he is a working guy. So yeah, we're gonna get on this. I'm gonna practice my TIG welding skills, and
I bet it's gonna make at least 800.
Yeah,
I bet.
Mm-hmm.
I wonder how that'll be like on a completely stock 5.3. I mean, I know what people do.
We'll find out.
Well, it'll last for a little.
I mean,
bit.
I'm not changing nothing. Camshaft, anything. This is going to be like we've added said turbochargers.
We're gonna find out.
Right.
All over YouTube, dude.
Yeah.
Oh yeah.
Yeah.
We'll make Mike famous.
Oh, you mean put my shit on YouTube?
Well, we're gonna do that too.
No, but that kind of shit's all
Oh,
over
yeah,
YouTube.
yeah.
Oh yeah.
All the stock 5.3s are flying.
Oh, we saw the 9-second ones that Matt. tuned,
Somebody
isn't
went
it?
to sevens. Didn't
Sevens?
Yeah, with a
they?
Mustang.
Yeah.
Oh yeah, the Mustang, not a Tahoe.
Yeah.
He went
Well-
9 something, like just touched 9s, I think.
All right. Well,
Mhm.
we're going to get started on this. So we got some parts. So a couple other things I got to figure out. I got to get with Paul on injectors, figure out fuel pumps or how and what and why the best, because that is a fuel pump control module. That gets a little different than the regular cars.
Yep.
Because it's a flex fuel. So I don't know. We'll figure it out. But this is going to be fun. I really can't wait to get this done. All right. Anything else?
Nope.
Bueller? Anything from you, Tad?
Yeah, I can tell you what else uses eddy current brakes.
What's
They have
that?
huge heat exchangers. SD42s, electromotive diesels, big trains.
He did say trains.
Yes.
Yep.
Where you
The
been?
first
Yeah.
thing he said.
Yeah, first thing he said.
Yeah.
Build the Tad.
Never mind.
Oh, God. That could be a meme
It's gonna be.
with a little checklist. All right. Well, we'll see all y'all next week. Bye-bye.